Hello viewers, welcome to Chris Study Studio. Today on mathematics, we will be dealing again on basic operational signs in equation. We want to look at how these operational signs process, how they move around, how they interchange when they are used in equations. And so when we make reference to basic operational signs, we are looking at the addition, subtraction, multiplication, division, powers, and roots. So we look at it as we have the addition, the subtraction, the multiplication, the division. We have the power, say a variable raised to power. Let's use P as power. And then we also have a variable that is in the form of roots. But let me first put this as inverse of the power, and then we eventually explain how why and how it is used as roots. Okay. We are going to use a concept to conceptualize these basic mathematical operations. So the concept we are going to use is that we create a scenario or a picture, an imagery, that there are two families that live side by side and have either a common fence or a common bridge that separates the residence of these two families. Say family A, and then in between there is a bridge or a crossover, and then to family B. There is a certain relationship they hold. If we say that the children of family A from maybe level of seniority are power, so we can say X to power is the most elderly, but this X to power is the most elderly is a friend to let's say Y to inverse of power. We are using variable X to mean any number and variable Y to mean any number that may fall in that process. The next after power is multiplication. So let me properly write this X in this way so that it will not confuse us with this. So this will be taken as multiplication. This will be taken as X as a variable. Then this is multiplication. By the side of family B, we have division. If X to power is elder to multiplication, multiplication is elder to addition, and addition is friend to subtraction. You will notice that this is from the lineage of family A, this is elderly, next is multiplication, and then addition. Here, Y to inverse of power is eldermost, next is division, and then subtraction. The remarkable thing is that these two are friends. We can say they were born the same day, so they are good friends. They share a very good relationship. These two are equally friends, and these two are friends as well. So in between them, we can say there is a fence that separates the two families. We might as well say there is a bridge. So we are going to take it that this is a bridge that also implies the fence. So if we kind of let's use something like this to help us illustrate better. So there is also equality here. There's equality here, and there's equality here. So what this means is that when this chap wants to visit the other side, when anybody from this family wants to visit the other person from this family, its function changes. What this means is that if a variable is raised to any power, once that power switches, because the function here is power, the emphasis here is on power. Once this power tends to move and cross this equality sign, the equality sign represents the bridge. Once this power crosses the equality sign, it changes to its friend, its functionality, its operation changes to its friend, which is inverse of that power. Now, this inverse of this power is what we know as roots. So, in this case, you will have it as p root. So, this index power reverses itself as 1 over p. So, the index here is the reverse of this index here when it crosses the bridge, called equation, equality sign, which also can be expressed as roots, the p root of y, just like we say the square root of y. So the same thing happens here if we have an inverted index and it crosses to this side, its operation changes. If it is an inverted index, here it becomes an index. So if it is a root, which also means this, if it's a root, if it comes here, it becomes a power. So if we are using this for emphasis, power, when crosses equality sign, changes its operation to become a root. When a root crosses the equality sign, it changes its operation to power. So exactly the same thing happens with multiplication and division, addition and subtraction. Whenever they are in any mathematical operation, you will notice that multiplication, when it crosses, if anything is undergoing the operation of multiplication, if it crosses the equality sign, it becomes division. Likewise, if division crosses in whichever way, it becomes multiplication. So the same thing, if something, an operation is under addition, once there is need for it to cross an equality sign, it changes to subtraction. And if there is any function undergoing subtraction operation, if it crosses to the other side, either left or right, as the case may be, the subtraction becomes addition.